the beginning, there was an idea, an autonomous snowplowing robot. We started with many questions. Existing systems were analyzed, disassembled and rethought. Step by step, concepts turned into reality. The first 3D models were created. Components were designed, printed and refined repeatedly. Once all parts had arrived, surface finishing began. The components were sanded, primed and painted. For the final design, we chose a clear combination of blue and white. The assembly of the main body followed. Initially 3D printed connection parts were used, but were later replaced by metal components to increase stability. Motors, gearboxes and connecting elements were integrated. The entire track system was also designed and assembled in-house. Rollers, track guidance and tension were adjusted and tested. Next, we focused on the electrical system. Cables were routed, subsystems connected and the battery integrated. The energy storage system was developed entirely in-house. 5.3 kWh capacity, built from 16 lithium iron phosphate cells. The system delivers the required power reliably. A key component is the snow blade. It was welded, mounted and equipped with 4 linear actuators. This allows the blade to be precisely controlled along 2 axes, adapting to terrain and snow conditions. With the mechanical system completed, we turned to the sensors. A custom-designed sensor box was mounted. It integrates a LiDAR, a GNSS antenna, an IMU, a depth camera and a RGB camera. All sensors were calibrated and integrated into the overall system. The big moment had arrived. We powered on the robot for the first time, and it worked. LYNX drove and even climbed some steps. In parallel with the hardware, the software was continuously refined. Navigation, object detection, snow detection and motion planning were improved, both during the day and at night. Finally, the moment arrived. LYNX was able to drive autonomously. Now we wanted to see how it would perform in snow. We loaded LYNX into the car and headed to the mountains. It was clear, LYNX drives. After 9 months and more than 2,000 hours of work, development, designing, building, programming and testing, our autonomous robot was complete. And it is ready for the next step. Its journey to the United States.